relatively soon. So today's kind of an exciting day because we move on to Chapter 7, Arrays in the Array List class. We'll start off with Section 7.1, Introduction to Arrays. And a lot of the notes from 7.1 come from an honor student from last year, last semester, Nicole Sheehan, who did a really nice job summarizing the important points of that section. So I'll be using her notes. We'll talk about processing array elements in 7.2 and passing arrays as arguments to methods in 7.3. We'll see that there are some useful operations to do on arrays, like finding the largest and smallest element, which we'll check out in section 7.4. And then in section 7.5, kind of the reverse of arguments as arrays, we'll do arrays as return values. In 7.6, string arrays, and 7.7, arrays of objects. 7.8, a cool algorithm to find an item in an array, the sequential search algorithm. And in 7.9, hey, welcome. We'll check out not one-dimensional arrays, but two-dimensional arrays. 7.10 is optional. It kind of is an extension of 7.9. It's arrays with 3 or more dimensions. But in the interest of time, we'll kind of read that as an extension of 7.9, and we'll skip to 7.11, the selection sort and binary search algorithms. So these are two super cool algorithms that are used on arrays to sort them, put them in order, or to search them, find an element. 7.12, we'll take a look at how to use the command line to read in arguments. And in 7.13, we'll check out a class that is super useful for dealing with related items in the array. And then 7.14 are common errors to avoid detection. That's just going to be optional as well. Good morning, Paulina. Good morning. So we know that most variables only hold one value at a time. For example, here's an int variable called count that stores one value, the value 4. Here's an example with a float variable called price that stores one value. It's going to be 499. Arrays work like a variable that can store several values. The values are stored together like a file in adjacent memory locations. The parts of an array. To make an array, you'll need the data type, then the name of the array, then the size of the array, so how many variables it's going to hold, in brackets. So the format is data type, array name, and then size of the array in brackets, like these square brackets. The size declaration indicates the number of elements the array can hold. It's the value that's put into brackets. And it can be a literal, like 6, or it can be a constant. In both of these cases, the array has a size and a set, but the first one uses the literal, the 6, and the second one uses a constant, the number of days. Elements are the values that are stored in an array. And the values in the array are stored in the computer together as a group. In other words, there is a date and number. This is what the array looks like where it's stored and used. So the individual values of the array, the elements, can be specifically named by what order they appear in the array. The array number starts with 0, so the first element is really element 0. Oh, thanks. Oh, cool. I'll answer this round again. If you're curious, the amount of memory used for an array can be found by multiplying the size of each element. So for example, for an int array, by the number of elements. So this 6-element array, if they're all ints, we'll take up how many bytes in memory. Yeah, sure. 30, close, really close. So 4 bytes per int, and there's 24, yeah. How come more? Hey, yeah. Oh, maybe. Oh, so, so yes. Awesome. Cool. Yeah, exactly. 6 values, 4 bytes for each value, so 24 bytes total. So this array takes up 24 bytes of memory. How can we access or use specific values contained in an array? Well, each element in the array has a subscript, and that's its position. The subscript categorizes the element from first to last, and the elements can be accessed and used as a variable by accessing that specific element within the array. So the first value has index 0, the second value has index 1, and so on and so on. Just remember that subscripts always start at 0. So an array of element 6 has subscripts from 0 to 5, not 1 to 6. So the way to access an element is with this format here. The array name, and then in square brackets, the index, the number of the element that you want to access. Once an element is accessed on its own, you can treat it the same way as if it were a variable. So for example, if we wanted to assign the value 45 to all of the elements in an int array called days, then we could do that. We could assign 45 to the first element just by saying days at position 0 equals 45. And then we could do that for the second element. The third element, the fourth element, the fifth element, and the sixth and final element. The array size declarator is not the same thing as the array subscript. So before, when we have this size declarator of 6, that's different from down below where we're actually accessing specific elements using their subscript. If you don't like this format here, there is a quicker way. You can enter values into an array all at once using array initialization. In other words, you can initialize arrays similar to how you initialize variables, but instead of just one value, like with variables, you can put curly brackets around the group of numbers. So for example, let's make a final int called numWeeks and set it equal to 7. And then let's make an array of ints called day of the week rating. And let's use numWeeks as the size declarator. We can use an initialization list to put in the values directly. So 10, 9, 8, 7, 6, 5, 4. And this will have the effect of placing the 10 at position 0, the 9 at position 1, the 8 at position 2, the 7 at position 3, the 6 at position 4, the 5 at position 5, and the 4 at position 6. So an initialization list is a list of numbers, or really values, that you initialize an array with. The values are entered in the array in the order that they are entered in the initialization list. Any questions or anything? Initializing the array not completely is okay. Any values that aren't initialized will be initialized to 0 by default, or a falsy value, meaning 0 for numeric types. False for Booleans, and null for objects. So like in float and double, the numeric types would get initialized to 0 if they weren't explicitly initialized. Same with Booleans, they would get that falsy value of false. And then an array of objects, if any part of it, wasn't initialized, then it would just get null. Except a null pointer there. So for an example, maybe we have a variable called numPeople, and it's set to 8. Hey, welcome, Nick. And we ask how hungry they are. And we store the results in a array called people hunger meter. And let's say the first person, responded with a 4, and then the second person 6, and the third person with a 4. We could fill the array this way. But the array has 8 elements. So what's this array going to look like in memory? Yeah, awesome. Good call. 464,000. Yeah, all the rest would be zeros. Good call. Cool. Awesome. And I'll put the subscripts down here. And yeah, that's exactly right. Yeah. You can't skip values from so just for a bad example of something not to do, declaring a numbers array of ints size 6, and then trying to, do something like this, skipping values in the initialization list. This won't work. Oh yeah, sure. To this part? Or... Oh, cool. Yeah. No problem. The cool thing about initialization lists also is you don't have to enter the size of your array. What happens is called array size. So all that means is the number of elements that are in that initialization list becomes the size of the array. If you don't declare it beforehand. Yeah, Jack.
Yeah, good call. Uh-huh. Yeah, so good call. Yeah, so the way to do that would be yeah, don't use the size declarator and then just put in the four values in the initialization list. Is this what you're asking about? Cool, awesome, yeah. And then right, this array would have a size of 4. Uh-huh. Thanks to that implicit array sizing. So any questions about that? Okay, so then I have a challenge question for you. Oh yeah. Oh, the underscore. Yeah, that's I don't know. Um, for some of the identifiers, Nicole chose to use these underscores for the spaces, and that's cool. You'll see that too. Yeah, it's just in the space. Yeah, uh-huh. Yeah. Um, yeah, that's kind of you'll see that too. Some programmers they'll instead of the camel case with the lower and uppercase words, they'll put all lowercase with like underscores. Um, it's just up to us. If we did, then we'd have to keep it consistent. Like this. Yeah, or even we could do the underscore and the capital. Kind of, yeah. As long as we keep it consistent, it'll work. Yeah. So okay. So who can answer this question here? The value of s at position s at position 6 minus s at position 5 is what? Negative 3, 3, 2, 9. Got both of them. Someone just said 9. Do you want to walk us through? Yeah, okay, Rosa. Yeah. Cool. Uh-huh. Uh-huh. Cool. Okay. Awesome. So right. So if we copy this down and start with S at position 6, Reza said that that is 3. So I'll just replace that with the 3. Oh, 6. Sorry. It's 6. Uh, at 6 is 6. So then we'll replace that with a 6. Yeah, sorry. And then and then subtract S at position 5. Awesome. So then if we do the same thing with S at position 5, that's 3. And so we've really got S at position 6 minus 3. And the 6 minus 3, well, that's just going to be 3. And then S at position 3 is 9. Yeah, so that's our answer. Oh, yeah, right. So it's a lot of kind of going back and forth. Yeah. Any follow-ups or anything? Cool. Okay. So then, in that case, I think we have a good understanding of this section. So any follow-ups or anything before we move on? Yeah, for sure. Yeah. Yeah. Oh, yeah. Could someone? Uh-huh. Oh, yeah. Yeah, I guess only if there's the S in the brackets do you want to go back into the array and see what the value was. But if it's just like 6 minus 3, um, that part, yeah, it can just become 3. Oh, that's this one here. Yeah, this one here. Yeah, yeah, maybe. Oh, this one? Yes, exactly. Right. Yeah, good call. Good call. Yeah, it's really subtle. Yeah. Yeah, it's these like empty spaces. So let's get an array that'll just store the number of days that's in each month. I guess without any leap years or anything. Okay. So let's say that this is our array, and it's got 12 elements, but the indexes just go from 0 to 11. And let's say that we want to print out just the numbers in this array. So to do that, we can use a regular for loop, or we can use an enhanced for loop. Let's start with the regular for loop. So a regular for loop would just have some variable like x, and it's probably going to start at 0 if you want to go through all the elements. And it's going to go up to, well, we could just put a 12 here, but really the best way to do this would be to put days in months dot length, or whatever the array name is, dot length. And so for this array, which is, let's say it's called days in months, is going to be 12. And then let's just increment x by 1. So we really just need one statement to print out all the elements in the array. Can anyone think of it? Yeah. Uh-huh. Okay. Uh-huh. 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 Okay, cool. Okay, yes. Okay, okay. Uh-huh. Okay, uh-huh. 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 Like that. Okay. Like that. Oh, yeah. Okay, not bad, but we can change a few things. I think maybe some things we can change. Yeah. Cool. Okay, awesome. Sounds good. Yeah. How come? Yeah. Okay, close. Yeah, close. Yeah, X is a variable and it's kind of representing the. Okay, cool. Like where 0 is January and 1 is February and okay, cool. Awesome. So it's kind of like the position. Okay, awesome. Nice. This sounds good. Yeah. Oh yeah. Well, actually we don't need those. Those would just be optional here. But it's nice to group X and the 1 together because we want to print out like month 1 has 31 days for January just to be a little more user friendly than month 0 has 31 days. So we'll just add 1 to the index or the position each time. Yeah. And yeah, the parentheses are optional. Yeah, there. How do we feel about this part here to get the 31, the 28? Because I think you just said X is the position. So where should that go? Should that be a part of this somewhere? Uh-huh. Yeah, good call. Days and months. Let's exchange it for X. Yeah. And then what about days here? Good call. Yeah, let's use days and months. Yeah, awesome. Cool. Nice. So this is saying, yeah, we'll print out the month, the position plus 1 has, and then the, you know, value that's at days and months at position X. Yeah. Yeah. Yeah, good call. Totally. Yeah, good call. Good call. Yeah. Oh, out here? Actually, no, because the way to access an array element is with the array name first, and then in square brackets the position. Um, so since x is just an int, just an int but not an array, yeah, we couldn't use like x and then brackets. Yeah. Does that make sense? Or any questions, follow-ups? Okay, cool. So it actually turns out this would be actually kind of hard to write with an enhanced for loop because we want access to that counter variable that's going from 0 to 1 to 2, so the x. But we can at least print out the values in the array using an enhanced for loop. And actually, we could add in the part about the month number as well. So this for loop here, it would just actually print out the 31, the 28, the 31, the 30, and so on and so on. The enhanced for loop, it steps through every element in the array, just in order from first to last. But the drawback is it's kind of hard to use the index explicitly because we don't have like a variable x anymore. But we could add that in. Can anyone think of a way to add in a way to make this equivalent to the one before it? And we can run the NetBeans and see. Cool. Okay, awesome. So yeah, tell me a little more. How would... Cool. Sounds good. Yeah, sure. Let's have it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, sure. Yeah. We should probably call it something else like since it's going to be an array, we could call it like int array y or something. And then just put in those numbers here. Cool. Sounds good. Oh yeah, just to if it's going to be an array, um, then we couldn't use x again because it's just a single int. But we could have used anything other than x. Really. Yeah, it's kind of tough. Yeah, Lon. Oh yeah, that's actually they could go either place. It's kind of weird, but yeah, I think our book puts them after the array name, but you could actually put it after the data type. Yeah, yeah. This is an interesting way to do it. I'm not sure. Will this work? Can we think of a way to make it work? I'm not sure. Well, let's run this program as it is, and then let's see. Maybe we can maybe it'll be easier in NetBeans. Yeah, project. It's called processing array. And let's put in our code from before, and then I'll just go source format. Oh, and it looks like we have to get the days and months declaration, so throw that in here. Who can tell us how to declare the days and months array and initialize it? Yeah, Jeremy, yeah. Yeah, what do you think? Or anyone, yeah. Oh yeah, let's initialize days and months, yeah. Okay, cool. Yeah, days and months. Uh-huh, yeah, close. Let's go with the, uh-huh, yeah, cool. All these, uh-huh, 8, 31, 30. Cool, okay, awesome, cool. So it sounds like uh, whether if we're choosing whether to go with the positions or the values, let's just go with the values, and the positions will get automatically kind of like uh, you know inserted for us, or kind of placed in there for us. Yeah, that might be the hardest thing we do. This chapter is filling in the yeah dates. Okay, cool. So now let's go ahead and run this and see what we see. So here's just our code from before. Run it. And it looks like from the first for loop, we've got month 1 has 31 days, month 2 has 28 days, and so on and so on. And then we've got from our enhanced for loop just the days, just the number of days, um, which is fine. Yeah, that's fine. we wanted to make them similar. Anyone have any other ideas? I'm not sure that another. Uh, well, I'm not sure. Yeah, I don't think another for loop would exactly work. But we can make a counter variable. Yeah, if we wanted to. I mean, I don't know if it's a big deal, but maybe it could be extra credit as to make the enhanced for loop give the same output as the regular for loop. Yeah, and one hint might be to make a counter variable start at 0 and then increment it inside the for loop. But the main point is there are at least two ways to step through each of the elements in an array. One's with the regular for loop, like in lines 20 through 22. And it's got some extra stuff in there too, but the most important part is this right here, days and months at position X. Or using the enhanced for loop, where you don't really have a counter variable, but you just have an int, and it's going to take on the values of all of the elements in the array. So val is going to become 31, and then 28, and then 31, and then 30, and so on and so on. So two ways, yeah, to step through every element in an array. The drawback of an enhanced for loop is, as we can see, kind of lose some of the control over accessing individual elements. You have to access all of them. And you don't have control over accessing them in order. They have to go first to last. But you can't like go last to first, and you can't like skip every other, every three, or something like that. Yeah. So it's good. It's kind of like a short and sweet select shortcut. But it's not always appropriate. Yeah. Oh yeah, actually we don't. Yeah, we don't. We could get rid of that or comment it out. Yeah, we actually don't need that line. It's I think it was like the kind of like the start of a suggestion from earlier, but now that I think about it, maybe we should leave this for extra credit and move on, and yeah, we can run it again without that line. All right. Any other questions or anything? Yeah, sure. Oh, yeah, 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 yeah. Good call. Because Val is going to be like the 31, the 28. Yeah, yeah. So blah 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 has Val days. Yeah, good call. Cool. And we could do another quick example of a regular and enhanced for loop. We could just make a double array called numbers, and we could set it equal to 3.6, 6.7, and 2.9. And then we could use the regular for loop and the enhanced for loop to just print out the contents. So with the regular for loop, we could have integer variable, let's call it I. Start I as 0, and as long as I is less than numbers.length, then increment it by 1 and print out numbers at position I. in the wrong place, by the way. And then who can rephrase this as a enhanced for loop? And maybe we could even print out a line that says, just to separate things, behold, enhanced for loop. And then maybe a line up here just says regular for loop. Yeah, so can anyone rephrase the for loop in lines 32 through 34, starting in line 37? Yeah, so we want to rephrase the for loop in line 34 for loop in line 30. Uh-huh. Yeah, nice, awesome. Uh-huh. Yeah, sure. Uh-huh. 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 I saw the colon. Yeah, uh-huh. Sign for the colon. Cool. Uh-huh. Uh-huh. Yeah. Good call. Good call. Awesome. Okay, does everyone agree with that? Okay, let's run it and let's see. Okay, cool. So our output from before is still there, and then now we have the output with a regular for loop, and we're seeing the values, and then in the enhanced for loop. So here's from Jiang's solution. So we're seeing the values printed out, but using that enhanced for loop. So any follow-ups or questions? Yeah, this part. Yeah, you're Oh, good question. Okay. Yeah, why is I using int? Should it be using double? Well, is I taking on the values in the array, or is it taking on the positions of the values in the array? Positions, yeah, huh? And the positions are always int. Like there's position 0, 1, 2, 3, 4. Uh-huh. Even if the values in the array, those positions are not ints. Like in this case, when they're doubles. Yeah, that's a great question. I'm glad we have this example because with the last one where there were just ints and ints, yeah, it's a little hard to um, tell the difference there. Uh, yeah, I think it would, but it's just not really done. Yeah, we could try it just for an experiment like this. Oh, it looks like yeah, looks like the subscripts can only be ints. Uh-huh. That's probably a good thing. Okay, cool.